sine, a single trigonometric ratio with an angle and then basically a numerical value on the left hand side or the right hand side. Sine theta is equal to half. There's two things you need to check here. You ask yourself, sine theta is equal to half. This means basically that sine is positive. So you are always asking yourself the question, where is sine positive? Okay, where is sine positive? Sine is positive where exactly? Okay, sine is positive in the first and it's also positive in the second quadrant. Very important, that thing. Okay, that sine is positive in the first and in the second quadrant. Okay, very important that that's the case. Then you are going to say your reference angle is equal to the inverse of sine. Okay, and basically that will be what? What's the inverse of sine? Inverse of sine, or arc sine they call it, of half. What do you guys get? I'm trusting my people that have their calculators to be able to assist me here. Thank you, 30 degrees. So guys, we call this the reference angle, because when we are doing general solution, what we want to do is we want to utilize that reference angle, and we are going to check in the first quadrant, meaning in quad 1, and in quad 2. Remember, we said that sine is what? Is positive where? In the first and in the second quadrant. Now obviously, in the first quadrant, that simply means that theta is equal to 30 degrees plus k of 360. Okay, where k is an element of what? Integers. Okay, that's for our what? Our quadrant 1. Okay, then for quadrant 2, theta is equal to, that's going to be, remember, in the second quadrant, this quadrant is the 180 minus quadrant. So we are going to say 180 minus the reference angle plus what? Plus k 360, where k is an element of integers. So 180 minus the reference angle, that's theta is equal to 180 minus 30 degrees, which is very important. 180 minus 30 degrees, the reference angle, plus k 360, and then 180 minus 30 is 150 degrees plus k 360. Okay, and let us not forget that k is an element of integers. So these are two general solutions, one in quadrant 1 and another general solution in quadrant 2, which is 150 plus k 360, where k is an element of integers. Okay, so I hope we understand how we got the general solution of sine theta is equal to half. And as per the rule, because we want the general solution, for this particular step here, we write this, we say this is the reference angle. Okay, then we utilize the reference angle to then be able to write our general solution for each respective quadrant. So for quadrant 1, theta is equal to 30 degrees plus k 360, where k is an element of integers. We're looking at the fact that the period of the sine graph is 360. So we say k 360. And likewise, obviously, whenever we're writing the general solution, we add a multiple of an unknown 360 degrees time. So that's very important. Okay. Okay. So I hope that's clear for one and all. Okay. Usually, for different problems, it's a matter of being able to know how to get out of the woods. Okay. So for this one, this is how we get out of the woods. Okay, let's look at another one. Number 2. Slightly different in this way. This is 3 sine x is equal to negative 2. Likewise, again, we are being asked to determine what? The general solution. So step number 1. 3 is a coefficient of sine x. We have negative 2 on the right hand side. So it exhibits linear qualities, this one. So what do? We divide both sides by 3, because the coefficient of sine x is 3. So we are going to get sine x is equal to negative 2 over 3. We have now officially isolated the numerical value. We have the trig ratio on the left hand side. Then we ask ourselves this question: where is sine negative? Where is sine negative? Because here, what did you ask? Where is sine positive? And that helped you to be able to identify the quadrants which you will be utilizing the minute you write your general solution. So once again, we are going to utilize the same thing and ask ourselves, where is sine negative? Where is sine negative, guys? Which quadrants is sine negative? Because I'm going to identify those quadrants. Where is sine negative? I'm going to ask you guys. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Which quadrant is sine negative? Nombulelo, thank you. 3 and 4. Okay. Which quadrant is sine negative? Yes, it's negative in this quadrant, which is the tan quadrant, and also in the cos quadrant. Okay, so that's where they are negative. So I know when I write my general solutions, I'm going to be using for my reference angle that 180 plus the reference angle and 360 minus the reference angle. I'm definitely going to be utilizing those because that's where sine is negative. That then allows me to say a reference angle is equal to, I take the inverse, okay, and then I say 2 over 3. Okay, the logical thinking here is that because I've asked where is sine negative and have then identified the quadrants, okay, where sine is negative, when I work out the reference angle, I want the reference angle to be an acute angle that is positive. And I mean, that's the same thing here. We want the reference angle to be an acute angle that is positive. There's a deliberate sort of like pursuing of a reference angle that is positive. So therefore, what we do is then we say the sine, okay, inverse of 2 over 3, okay, not negative 2 over 3 but positive 2 over 3, because we've already accommodated the negative sign by asking where is sine negative. So that then allows us to write the inverse of sine 2 over 3. Are you with me? Or arc sine 2 over 3. Then I utilize my calculator. Or if I don't want to and I am interested in only rounding off at the end, you can actually retain this thing here. All right, and then when you go to the quadrants, we know this is quadrant 3 and quadrant 4. So in quadrant 3, you are going to say, you see, most this the variable, it's x and it's single coefficient x. So x is equal to 180 plus. All right, and because I'm going to round off only at the end, I'm just going to say sine inverse of 2 over 3. Okay, plus what? Plus k 360, where k is an element of integers. Okay, yeah, but I mean, it's fine. I think there's someone who actually said 41,81, and that was rounded off to 1 decimal place. I mean, that's someone who wants to be able to see. But remember the reference angle. Okay, we do round off, but we round off at the end, guys. It's very important. We're rounding off at the end. Okay, so that's for quadrant 3. We say 180 plus. And then for quadrant 4, we are going to say x is equal to 360 minus sine inverse of 2 over 3 plus k 360, where k is an element of integers. Okay, then we can roll this out in the calculator. What's the answer, guys? X is equal to 180 plus 41,81. We get 221,81. And then here x is equal to 360 minus 41,81. We get what, guys? What do we get? 360 minus sine inverse of 2 over 3. What do you guys get? What's the value? No ways, it can't be 381. No ways, I disagree. 360 minus 41,81. Thank you, Nombulela. I was like, what? Okay, there it is. General solution vibes. Okay. Any questions? Any questions at all? Any questions at all? Okay. No problem, Mbulelo. It's understandable. It was not deliberate. You made a genuine mistake. Okay. Please, guys, take note of this thing. Negative 2 over 3. You ask yourself, where is sign negative? You identify the quadrants. Allows you to write negative 2 over 3 as positive 2 over 3, so that when you express this, it is a positive acute angle, which is your reference angle. Then you can utilize that in the quadrants. 180 plus the reference angle with 360 minus the reference angle. And that should actually work out very nicely and smartly for your general solution. Okay, I hope that method is clear for you guys. Let's go on to another type slightly. Okay, can you see this one? Cos 2x plus 10 degrees is equal to a half. Ready to go, ready to go, ready to go. Ready to go? Can we go? Can we do it? Cos 2x plus 10 is equal to half. So here we actually have what we refer to as a compound angle, because this is cos of 2x plus 10. This is together. This is a household. There's a father, together with a mother with kids. They are all inside the house. It's so nice and warm, and they cannot be disturbed. Cos obviously is the trig ratio. This is the angle concerned. It's a compound angle, which is equal to a half. So guys, let's go. First step number 1, which is very important. We take the arc of cos on the right hand side. Okay, but before that, which is very important to note, first thing we do, okay, cos of 2x plus 10 degrees equal to half. We first ask, cos is positive. Where is cos positive? This is very important. Where is cos positive? Okay, where is cos positive, people? Where is cos positive? Thank you, Nombule. It's like Nombule is really like helping me out here. I don't know if like everybody else is. So cos is positive in the first and the third quadrant. Very nice. Very, very nice. First and third quadrant. Then cos of 2x plus 10 is equal to a half. What we do is we find the reference angle of what? of cos the inverse half, arc cos of half. Okay, so the reference angle is equal to what? What is it, guys? Inverse. Niliwa, thank you so much as well for answering that question. Thank you, 60 degrees. So our reference angle is 60 degrees. Then what do? We go to the quadrants. We have quadrant 1, we have quadrant 4. So for quadrant 1, we know we are going to have, on the left hand side, we have 2x plus 10. So we are going to write 2x plus 10 degrees. Okay, please take note of that, guys. Take note of this. There was a 2x plus 10, the family. The family, it comes down to the quadrants. On the left hand side, we say it's equal to what? The 60 degrees. 60 degrees plus what? Plus k 360, because we use that period of what? Of course, to be able to write multiples of that particular period value. Okay, because now we are going to revolve around and around and around that unit circle. 0 to 360, from 360 to 720, from 720, and so it goes. So basically we are going in multiples of that 360 so that we can venture into the other quadrants for other intervals greater than 360 and for intervals that are less than 0. Okay, this is a general solution is supposed to accommodate infinite number of values across intervals for both negative and positive angles. That's why we utilize a general solution, because we are no longer limiting ourselves to a particular quadrant. Like in grade 10, you guys were limited to operate in the quadrant 0 to 90. You basically could only find the values of x between 0 and 90 degrees. When we go to grade 11, we open up the world of the interval that we can actually find values of the unknown angle. Okay. Oh, Nelly was said 1 and 3. Oh, you guys said 1 and 3. Okay, all right. I think in my head I was just like, obviously there's these two, and we know it's 1 and 4. And why is it 1 and 4? Because cos is positive in the first quadrant. All trig ratios are positive here, and then in the fourth quadrant it's also positive. Okay, in the third it's negative. Okay, so I did take 1 and 4, and in actual fact I indicated 1 and 4. I think I didn't really I don't know, maybe I wasn't that focused on what you guys had said. In my mind, I thought you guys understood that it's 1 and 4. So yes, it's 1 and 4 indeed, Nombulelo. Okay, thank you for your guys' own personal correction. If you guys are able to see your errors, that's great. Then 2x plus 10 is equal to 60 plus k 360. That's for our first quadrant. Let's go to our fourth quadrant and see how we write the general solution. 2x plus 10 degrees is equal to, remember, this is the fourth quadrant, so we say 360 minus the reference angle. So that's 360 minus 60 degrees plus k 360, where k is an element of integers. Okay, let's go. Now we need to solve, and now this is algebra all the way. We transpose the 10 degrees. Guys, when we transpose the 10, we transpose it so that it can basically deal with 60 degrees. It's not like we transpose the minus 10 and transpose the minus 10 so that it affects things here. We just transpose the 10 because there are two terms here. So when you transpose the 10, we're just transposing it so that it becomes the third term. But then it gets added or subtracted to its like term, which is 60 degrees. This is an unlike term to 10 degrees. I hope that makes sense. Then it's plus k 360 degrees. So the answer, we have 2x is equal to 50 degrees plus k 360. And then interestingly enough, this coefficient of x, which is 2, we then need to divide by it. But we divide by it for each and every single term that is in the equation, including k 360. So that leaves me with an answer of x is equal to 25 degrees plus k, what's 360 divided by 2? 180 degrees, where k is an element of integers. This is my first general solution in the first quadrant. Then let's look at for the fourth quadrant. Okay, do we see the algebra? So all of this here is algebra. Now if your algebra is not make sure, then this becomes you make errors here. So our algebra must make sure, guys. Do you see how important it is that our algebra is make sure, 100% make sure? You see, please, may your algebra be make sure. Let not your algebra be not make sure. Allow your algebra to be make sure so that you may be made sure yourself. Okay, then let's move on to the fourth quadrant. 2x is equal to 360 minus 60, which is 300. We transpose the positive 10, becomes minus 10 plus k 360. This is 2x is equal to what's 300 minus 10? It's 290 plus k 360 degrees. Then we divide everything by 2. We get x is equal to 145 plus k 180, where k is an element of integers. Done. Okay guys, that was nice and smooth, eh? Yeah, so I think you guys surely must see that these ones are easy. There's nothing to it. Like all these problems, these ones, they are very nice, simple, to the point. There's nothing to it. Okay, nothing to it. Okay, then let's do one last one. Okay, I think I'm going to end the live here for today, and then next time when we have a session, I'm going to pick up where we left off as far as the general solution is concerned, and I'm going to look at other types of general solution questions. All right, and I'm sure you guys can see that I've basically built, this has been a built up, I've built up from simple, okay, to the most simple one, an isolated trig ratio with a positive ratio, a single trig ratio, which eventually leads to a negative, okay, then now a compound angle with a single trig ratio. How do I deal with that? And the fact that this comes down as family, this comes down as family for our left hand side of the equation. Now we're gonna do this one. Okay, nearly even with that one, the one that you've just posted, sine x is equal to 0.35. Okay, sine x is equal to 0.35. That problem that you've just shown me is similar to this one. It's not different. Okay, it's just that the remember, if you remember your remember, it is like this one, that one. You can actually do it yourself. All right, 0.35 is a rational number. It's just that instead of it being expressed as not, for instance, half is 0.5, they expressed it as half. So all you're going to do is you're going to follow the very same steps. Reference angle will be equal to sine, arc sine of 0.35. Then you get the angle. Okay, but first and foremost, you're going to ask is where is sine is positive. According to 0.35 is a positive number, so you're going to tick the quadrants where it's positive. Then you are going to say a reference angle, sine inverse of 0.35. Then find the reference angle. Then you come here to the quadrants. Theta is equal to, or in other words, you're not going to say theta, you're going to say x is equal to, and write the reference angle plus k360. And then you are going to say the x is equal to 180 minus the what? The reference angle plus k360, and solve. Okay, so for Neliwe, I hope you can see how your problem that you've just posted is just a type of this one. Okay, no different. First question, where is sine? Positive, because not 0.35 for you is a positive number as well. Then you tick the quadrants, you get the reference angle for the sine inverse of 0.35, you get the reference angle, which will be acute, obviously. And then you deal with the quadrants, man. Okay, so I'm not going to really do that one myself. You can do it because you at least now are familiar with the approach and the method of doing it. Okay. Guys are more than welcome to keep on posting. Now just show you and say, look, it's similar to this one. At the end of the day, the method is very simple and similar, guys, right? Okay. You may need to isolate the trig ratio on the left. If there's one single trig ratio, isolate it first. Then you ask yourself, that trig ratio, depending on the sign, is it positive or negative, in which quadrant? Then you write your reference angle. Then you go to your quadrants and you populate or write your answer in accordance to the reference angle, and what's on the left hand side. Look at this one. Same thing. We are going to isolate the trig ratio first. So because there's a trig ratio and it's one of it and there's a constant term. So we have 3 tan 2x is equal to negative 6. So here we need to do a bit of algebra before we can actually start doing the actual trig. Then we divide both sides by what? Because the coefficient of tan 2x is 3. Divide both sides by 3. So we get tan 2x. If we divide by 3 both sides, the 3 goes here. And here 6 divided by negative 3 is negative 2. Do you guys understand? So you divide both sides by 3. And we get tan 2x is equal to negative 2. Now, we are at that place. The trig ratio is isolated. 2x is a family. There's nothing more you're going to do, right? You're going to keep the tan 2x. And then we are going to write a reference angle is equal to tan. Just before that, though, tan is negative in which quadrant? Where is tan negative, guys? Where is tan negative? Tan is negative in the second and the fourth quadrant. Okay. Yeah. Then you take arctan of positive 2 because you've already accommodated the negative sign in the second and the fourth quadrant. Then inverse, tan inverse of 2. You guys tell me what's the reference angle? What's the answer of tan inverse of 2? What's the answer? Not 1 and 4, Nombulelo. 2 and 4. Oh, my network is bad again. Okay, then with tan, something very unique here is that if you use k of 180 degrees, you can write a full answer with one quadrant. You can write a full answer with one quadrant. Okay, you don't necessarily have to write the answer for both quadrants. If you use k 180 degrees, you can write a full answer with one quadrant. But if you use k 360, you have to write for both quadrants. If you use k 360 to write a full answer, use both quadrants. Use both quads. So I tend to love using this, to be honest. One quadrant, one answer, K180 accommodates everything. Okay. So that's why for tan I love using K180, because the period for tan is 180 degrees. For the basic mother tan graph, the period is 180 degrees. Okay. So I genuinely love using K180. So all you do is you identify one quadrant if you're going to use K180, and that one answer will satisfy everything. It just is like that. So we are going to write 2x. This is quad 1. So this is only applicable to tan. You're not quad 1, quad 2. 2x is equal to 180 minus 63,43 plus k 180 degrees, where k is an element of integers. Then what's 180 minus 63,43? It's 116,57. 116,56560, because you need to divide, at least you need to still divide that by 216,565. Okay, I'm just gonna write the entire thing. K 180 degrees, where k is an element of integers. Then we divide everything by 2. So when you divide everything by 2, because we only round off at the end, the final answer is actually negative. Divide by 2. No, it's 58,28 degrees plus k 90 degrees, where k is an element of integers. This one answer accommodates everything. That's why I say if you use K180, you can write a full answer with one quadrant. This is the full answer that will accommodate every value. So you can basically find all the values using this one quadrant. You don't need to basically write an answer for the fourth quadrant, okay, as if to actually say that basically makes it the full answer. No, one quadrant suffices and accommodates everything, as long as the period is 180 degrees. But if had you used the period 360 degrees, then you would have to accommodate both of your answers so that you can be able to have a full answer. Okay, guys, thank you so much. I'm going to have to love and leave you now, because unfortunately I can't stay any longer. I have to put my boys to bed. It's bedtime. But thank you so much. I really appreciate it. Hope you guys you found this a bit fruitful. Okay. If what? Pause it. Okay. Yeah, like I said, guys, I'm going to have to love and leave you. Let me love and leave you. I'll see you guys again. Definitely sure. See you guys tomorrow. Probably a little bit earlier, 8:30, if not 8 o'clock. Okay, we are going to continue on with general solution so that I can show you all the other types. I'll try and upload this video onto my YouTube channel by tonight still, so that you guys, those who may have missed it, can be able to get it. Okay. Yeah. But remember, we are interested in rounding off really truly at the end. But I get your point. Okay, Okay. Thank you so much, guys. Have a good one. Really appreciate it. Remember, when I wrote this, I just wrote the ... to indicate that there's more values, because I want to truly be able to round off at the end. Okay, but thank you so much, guys. Have a good one. Cheers.